Hello everyone, welcome to today's maths video lesson. I hope you're well. In the first video, we're going to be going over the solutions for the work sent out on the 12th of May. And in the second video, I'm going to cover the concepts of axis shifts. So this is the equation of the graph when the x-axis shifts up or down, and or if the y-axis shifts left or right. So we would have seen this concept of axis shift already when discussing parabolas and the turning point, but this concept can be applied for all the other types of graphs we've looked at so far. So at the end of today, we'll have covered all the concepts for the graphs, and then in the next few videos, I'd like to do more examples, just wrapping everything up and solidifying these concepts. So for the homework, the first question is, why is 2 to the minus x equal to half to the power of x? So let's start off with the left-hand side, 2 to the minus x. So our rule for exponents tells us that we must flip this and then change the sign. So it's 1 over 2, and when we change the sign, it goes from negative x to positive x. And this equals to 1 to the power of x over 2 to the power of x. I've just included this little step because if we take 1 and put it to the power of any number x, it just gives us 1. So if we put 1 to the power of 2, it's 1 times 1, which is 2. If we put 1 to the power of 3, it's 1 times 1, which is 3. And now we can use our distributive law for exponents, where we can take out the x from the top and the bottom, and we'll be left with a half x. So I imagine you might be struggling with this distributive law for exponents. So I just want to do a little example with numbers just to show you how this rule works. So if we have 2 to the power of 2 and 3 to the power of 2, the distributive law says that when we have the same exponent, that we can essentially factorize, we can take it out of each of these numbers. So this should give us then 2 times 3 to the power of 2. So let's check this works. If we look at the left-hand side, we've got 2 squared, which is 4, and 3 squared, which is 9. That gives us 36. And on the right-hand side, we've got 2 times 3, which is 6, and that's squared. So 6 squared also gives us 36. So we can see that this rule works with numbers. Let's just check with division. So if we have 2 squared over 3 squared, then our rule tells us we could write it as 2 over 3 to the power of 2. If we look at the left-hand side, we've got 2 squared at the top, which is 4, and 3 squared at the bottom, which is 9. On the right-hand side, it's 2 over 3 squared, which is 2 over 3 times 2 over 3. And our rule for multiplying two fractions together tells us we times the tops and times the bottoms. So at the top we'll have 2 times 2, which is 4, and at the bottom we have 3 times 3, which is 9. And this gives us the same thing. So we can see that our rule does work. And we're doing exactly the same thing over here as over here. It's just that our exponent, instead of being 2, is x. So we just take out the x like that. Next question. For values of x greater than 0, so positive values, is the graph of 5 to the power of x steeper or shallower than 3 to the power of x? So from our previous video lesson, we said that if the base is greater, then for positive values of x, the graph will be steeper. So if you're confused with this, let's actually check with some numbers. So I'm going to pick some positive values of x, 1 and 2. And we're going to see when we input these values into each of the graphs, what the y values will be. So for 5 to the power of x, when we substitute 1, we get 5 to the power of 1, which is 5. When we substitute 2, we get 5 squared, which is 25. For 3 to the power of x, when we substitute x, it's 3 to the power of 1, which is 3. And when we substitute 2, we get 3 squared, which is 9. So you can see when we compare the y values here, that the y values for this graph are greater than for this graph. 5 is greater than 3, 25 is greater than 9, 5 to the x is greater than 3 to the x for positive values. So the graph 5 to the x is steeper. Okay, so if we were to draw it, the graph 5 to the x would have y values which are quite high, and the graph of 3 to the x would be lower. Question 3, similar to question 2, for values of x less than 0, is the graph of 2 to the x steeper or shallower than 3 to the x? So once again, from the previous video, we said that if the base is greater, then for values of x which are less than 0, the graph will be shallower. So let's check with some numbers. So negative values for x, minus 1, minus 2. Graphs 2 to the x and 3 to the x. So if we substitute negative 1 into 2 to the x, we get 2 to the minus 1. And our rule says we flip it and we change the sign. And 2 to the power of 1 is just 2. Next value, 2 to the negative 2, we flip it and change the sign, negative 2 to positive 2, and that gives us a quarter. Okay, these values you can do on your own. I'm just going to write them down. 1 over 3, 1 over 9. So we can see that the y values for 2 to the x are greater than the y values for 3 to the power of x. So a half is a bigger fraction than a third, and a quarter is a bigger fraction than a ninth. So the graph for 2 to the x is greater than 3 to the x for x less than 0. So the graph, that would mean that 2 to the x must be steeper because it is greater. So the graph of 2 to the x would look like this, and the graph of 3 to the x would be underneath. Question 4. What is the reflection of the graph 3 to the x about the x-axis? So let's just recap x-axis reflections. Y, x. So whenever we reflect about the x-axis, we take this thing and we flip it. So it's almost like there's a mirror sitting on the x-axis, and it takes each of these points and flips them. So it starts here, moves this one here, this one goes over there, this one somewhere here, this one come here. So our graph would look something like this. Okay, in terms of the coordinate points, what have we done? Our original graph has coordinate points x, y, and we can see that we take each y value and we make it negative. So this y value for our original graph, we just make it negative in our reflection. And the same story for all the other points. So if this is y2, the reflection will be, it'll go from here and be like reflected, and it will make minus y2. So operationally, we make the y values negative. And what about the x values? The x values stay the same. So for the first point, this distance here matches this distance here. For the second point, this distance here is the same for the top point, and it's the same for the bottom point. So our x values are unchanged. So operationally, when we reflect about the x-axis, we make y negative and x stays the same. So that's all we're going to be doing for this equation. We'll make up the equation y equals 3 to the power of x. And our rule when we reflect about the x-axis says we keep x the same and we make y negative. So now we just move the negative over to the other side. So y equals negative 3 to the power of x. Next question. What is the reflection of the graph 3 to the minus x about the y-axis? So let's just talk about y-axis shifts again. Okay, this time we're reflecting about the y-axis, so we're flipping this shape. It's almost like there's a mirror sitting in the middle. So this first point gets reflected there, this point gets reflected, this point gets reflected, this point gets reflected, and we get something like this. So operationally, what have we done? Our original points are x, y on this side, and for each point, for each x value, we flip it, so we make the x value negative on the other side. So this one is negative x1. We look at this end point x2. Then when we flip it, this becomes negative x2. So what happens to the y values? The heights all stay the same. So this height and this height are the same, this height and this height are the same. So in essence, we're just making the x values negative and keeping the y values the same. Okay? X values negative, y values the same. So that's what we're going to be doing for this equation in question 5. Our equation reads y equals 3 to the minus x. And when we flip about the y-axis, we make x negative. So where we had x originally, we're going to write minus x. And we keep y the same. So this comes out to negative, and negative cancel, gives us 3 to the power of x. Okay, the last question is a reflection of the graph about the x-axis. So remember, reflections about the x-axis, we keep x the same and make y negative. Our equation is y equals 2 to the minus x. So we make y negative and we keep x the same. And now I'm just going to apply a negative to both sides. This changes to positive and this changes to positive, and that's our final answer. Okay, so on to the next video dealing with axis shifts.